Okay, hello everybody. Welcome. Welcome to today's webinar. It's called Beyond Observability with Humio and Instana. My name is Summer and I'll be your moderator. I work on the marketing team here at Instana and I'm excited to be hosting this session today. So I'm pleased to introduce today's speakers. We have Steve Waterworth at Instana and Grant Schofield over at Humio. Before I hand the mic over to Steve, I have a few housekeeping items to cover about this webinar. First, today's webinar will be available on demand after the live session and will be sent to you via email or through Instana's website. Next, we'd love to hear from you during today's presentation. So if you have a question for our speaker, just please feel free to send it through the Q&A box. We'll be answering questions at the end of the session. If we don't get to your question during today's webinar, we'll be sure to follow up afterwards with it. So without any further ado, I'd like to kick things off by welcoming our speaker, Steve. Steve, over to you.
Hi there. Good morning or good afternoon, depending on which side of the Atlantic you're on. Welcome to this webinar. We'll be looking at how Instana and Humio work together. So let's moving on. So as this is voice only, you get a couple of rather dubious mugshots. So Steve Waterworth, that's me, technical marketing at Instana, and Grant is here from Humio. He'll be speaking up in a little while. So that's Grant from Humio. So a little introduction into Instana. What we're attempting to do is make monitoring your microservices applications as easy and painless as possible, whilst still providing you great insight. And in order to do that, we believe these are the core capabilities that are required. Let's just look at those in a little more detail. So given that a microservices application has many moving parts, hundreds if not thousands of services, and typically in a highly agile environment with multiple deployments a day, how do you keep up with all of that? Well, you need an amount of automated monitoring and discovery. So what the Instana agent does is automatically detect new services as they're deployed. It recognizes them and then monitors them appropriately. For most language runtimes, that's entirely automatic. So your programmers can concentrate on writing features and fixes and not a whole bunch of instrumentation code. Context guides. So what Instana is continually learning is how everything is interconnected in your environment. So not just which services are speaking to which services, but also where they're running. So in which namespace, which pod, which deployment, what container, all that is continuously being learned, and that's held. And then at any point, you can see how a particular service that you're currently working with, or container or pod, you can see how it fits in the grand scheme of things and quickly navigate to it. So you get that context and the ease of navigation. Application perspective. So like I said, we have potentially hundreds, if not thousands, of microservices deployed. And of course, part of the services mindset is to have small teams working on a small number of services. So if you're in one of those small teams, maybe looking at the payment gateway, what you don't want to see is everybody else's services. So there's a whole load of extra noise there from services you may not necessarily be that interested in. So application perspectives is a tag-based filter that you can create. You can have as many application perspectives as you want. And that allows then those teams to very quickly just focus in on what they're interested in. And again, you get additional context from that application perspective. Pipeline feedback. As we're doing multiple deployments per day, one of the key things is knowing very quickly whether that deployment is a good one or a bad one. So we've just done a deployment, rolled out a new version of a container, and we want to know very quickly whether we can continue with that rollout or whether we need to abort that rollout and roll back. So with Instana, you're getting metric granularity at 1 second, and you're getting every single request traced, and all that data arrives just a few seconds behind real time. So say we're doing a canary deployment, we've deployed 1% of traffic onto the new version. It's very quick and easy to examine that, decide whether that new deployment has improved things or made things worse, and then continue with the deployment or roll back as necessary. As part of that ability to know what's connected to what and what's running where, this also then drives that root cause analysis. So with a highly distributed environment, the danger of ripple is immense. So if we have a data store at the back end there that's maybe starting to have some performance issues, and then there's a service or a couple of services that call that, and then there's other services that call those services, and other services that call those services, etc. And they get like, and it fans out. So one little problem at the bottom can have this massive ripple effect, and a whole bunch of services then start having problems. But it's actually one root cause and many effects. And what Instana does, because it understands how everything's interconnected and understands those dependencies, it can analyze that data in real time and pretty accurately say, hey, this is the cause, these are the effects. What you actually need to do is fix that data store, and all those other problems will go away. Traditional monitoring systems would just flood your inbox with 200 alerts and leave you to sort out what's what. And finally, on the unbounded analytics. So yeah, you do need to have a high look at your services and understand how at a top level they're performing, but equally you get those horrible little nitty-gritty little problems that only occur under a certain set of circumstances. So therefore you need to be able to cross-cut and find the particular piece of data that you're looking for, and the unbounded analytics gives you that capability. You can cross-cut through all that trace data of high cardinality and zoom in on the one handful of records that are causing you problems, get to that root cause, and effect a fix. So that's it from an Instana point of view. Grant, my colleague, is now going to take you through a quick overview of Humio's capabilities. Over to you, Grant.
Thanks, Steve. Nice to be with you, everyone. Like Steve said, my name is Grant. I am involved with the infrastructure team here at Humio. In addition to being very passionate about observability, I've worked in the space for quite a long time and have always enjoyed the realm of monitoring metrics, logs, distributed tracing, things like that. So I've been at Humio for the last year, bringing a new way to look at logging to people. So what Humio is a log aggregation platform. We run this as a software as a service, and we also do on-prem as well. So many of our customers, especially the ones doing tens and tens of terabytes of logs a day, are generally running that on premises. So we offer both those options. One of the things that really sets Humio apart in the market, or when compared to other logging solutions, is we have an index-free approach to logging. And so what this means is that we're not building a lot of large indexes like, say, a Lucene-based system would. So when you send 10 terabytes of data to Humio, we're generally compressing that 10 to 20x, and so that's only resulting in 1 to 2 terabytes of storage a day. So you're not needing to add more and more disk in order to make those logs searchable. And our approach is quite different in terms of how we're ingesting the logs, how we're parsing the logs, how we're storing those logs to make searching them really, really efficient even without indexes. So this allows you to send structured and unstructured logs. many environments, you have 100 microservices. When you have that many microservices, sometimes they come from different generations, or they used to be a monolith and now they're a microservice. And you can't always depend on the logging being exactly the same across all your microservices. In addition, Humio also supports metrics, and we'll see that a little bit in the demo later. So with our index-free approach to logging, this is giving you near real-time access to the logs, even if you're ingesting tens, 100 terabytes a day, because of our unique approach to how we ingest those logs and parse them. And like I said earlier, this can be done in a cloud environment, or in an on-prem environment, or a combination of both. And the way that Humio accepts logs supports most popular log shippers. So we have an Elasticsearch compatible interface, so you can use all of the beat tools like MetricBeat or FileBeat or WinLogBeat. In addition to, we support a Splunk HEC interface, and we also have the ability to listen on a TCP socket when you're in an on-prem, not a cloud install. You can open up a socket for TCP or UDP to stream logs in your own format. Next slide, Steve. So some of the benefits to index-free logging is this gives you access to high cardinality data. One of the really interesting things that we find when we work with security concerns is that you don't always have a good picture of what those logs are going to be across your organization, especially when you're a large enterprise. So being able to do things like search, just take an IP address, and regardless of where the field might be in your data, you can just search for that IP address across all of your data and really find those needles in the haystack. This gives you the ability to do ad hoc searching. And even if you're not sending structured data, you can actually structure your data at query time using variable extraction at query time, and we'll show this a little bit later in the demo. You're getting real-time access to tens of gigabytes a second as it flows through the system, because we're not indexing the data. You're not waiting for an index to be built, the data to be stored, and then a query to be run. So all of your alerts are functioning at sub-second latencies. Our 99th percentile, even on our cloud product, is less than a second for when we actually see an event to when you can run a query on it or send an alert on it. And this does away with this issue that we've constantly faced in traditional logging environments, where I really didn't have access to that data unless I indexed it, or I was always sending structured logs. And keep in mind that everyone's trade-offs are going to be different. The amount of data that you're searching and storing are different than someone who has regulatory concerns. And so what Humio gives you the ability to do with this index-free logging is store more of that data, so you don't actually have to decide which data is important and which data isn't, because you're not confronting the issues with adding more and more disk each and every time. Next slide. So Humio's approach to observability at scale, this index-free log aggregation, how does that work? So it starts with agents, which are the system sending those logs and stream processors. Though I think I messed up the slideshow. Can you bring that back?
You want to go back one?
Yeah. Oh, sorry. I just lost I just lost the picture of it because I clicked my screen. Yeah, there we go. Yeah, just keep going forward all through. We'll just move all the boxes. So from agents, we get to ingest, and that's where we authenticate the data, we validate that data, and we extract the fields. And so what that's generally going to look like is a parser, and we support many different kinds of logs out of the box. But many times when you're dealing with Nginx logs or proxy logs or things like that, you already have your format, and so we allow you to customize that for your needs. And then once we've ingested that data, we're putting it on a queue, And that's where the node's responsible for actually writing that data to disk lib. So we have the structured data that comes in after ingest, and what digest allows you to, our digest system allows you to do is this is where the live queries and live alerts are actually running. So you're not waiting for that data to get indexed, you're updating your dashboards and running alerts and building up the data that eventually gets stored onto disk. And then from there, once we've built up a series of segment files, then the last step is the actual storage step. So next. And this is where historical searches would take place. So you're generally you're concerned about your live data and how it and the queries and things that are happening in real time. But when we write that data to disk, it becomes essentially a giant MapReduce problem. And so we use lots of things like Bloom filter approaches and tagging and things like that, not indexes, in order to find that data efficiently when you're storing for storage for when you're doing a MapReduce historical query. Next slide. So finally, just talk a little bit about observability with Humio. It's not one size fits all, or even many. Your observability problems are going to be different because observability is really about having empathy for your user and understanding what your user's experience is. Your users don't care about how many nines you have for your uptime or even how many errors you have on your web proxy. What they care about is whether they're having a good experience. And when you approach observability from the standpoint of your user, and you have empathy for your user, you end up building dashboards and building systems that are about user, not about the CPU usage or your memory usage. Logs are the hub for the context across your system. So everyone has logs, and if you're storing them, there's always information you can find in those logs, and that information is valuable not just to your sysadmins or your SREs or your engineers. It's also valuable to the business as a whole. It's valuable to marketing, it's valuable to your product group, and it's also valuable to the executives. So there's a wealth of information in those logs that can really give observability about processes and users to the whole company, not just your engineering space. One of the things that I'm really excited about is as we build these systems that require systems like content delivery networks, we have all this really rich information at the edge that we need to collect and send into our logging and our metric systems as well. So integrating these systems, your web application firewalls or your CDNs or your Cloudflare information, for instance, is extremely valuable to actually knowing what your user is experiencing on the end. And you can transform your logs into metrics, and this is great for legacy environments where maybe you can't install an agent, or you have an older .NET application, or you have an older Java application that it isn't worth ripping apart to instrument, but you can generally get that information from logs and generate meaningful metrics for those legacy applications. And it's important to balance the compliance and cost trade-offs depending on your environment. So I think with that.
Yeah, so to carry on, we've seen a little bit about Instana and a little bit about Humio, so why integrate the two? There's, as Grant touched on, there's often legacy apps that you can't actually instrument. So there'll be some value in the logs that they produce. Quite often there's additional information that's in logs that doesn't get into a trace. So it makes sense to combine the two. Before we get into the demo, just a quick little bit on roadmap. So currently we have the quick navigation from Instana into Humio. We're currently working on quick navigation back. So from a Humio dashboard, you'll go, oh, that's an interesting piece of information. I wonder what's in Instana. If you want to get into a full trace or navigate around the Kubernetes environment, then you'll be able to hop back. We're going to be providing some dashboard templates to get you started on that. And then ultimately, we'll be putting the Instana trace ID, making that easy to get that into log messages. So therefore, you'll be able to have correlation via the logs. So you'll essentially be able to get all the log entries for a particular request, no matter how many hops it took or what technology was servicing that request. So let's have a quick look now. So this is the Instana dashboard. I've drilled in, and we're at the Kubernetes level. So we're looking at all the Kubernetes in my environment, which is just the one. We're actually running Stan's Robot Shop, our free sample microservices application, on a Kubernetes cluster to give us some data to look at. So drilling in, we get an overview of our Kubernetes environment. We have various namespaces in there. I'm going to take a look at Robot Shop namespace where our application is deployed. So again, we can see how much resource it's using, or whether we're getting close to any resource limits. And of course, we would get an alert once we were getting close to those resource limits. And just like standard Kubernetes dashboard type functionality, we can see all our deployments and the services, and we can take a look at, drill into those services. And here we're looking at our user service, and again, it's not using much CPU, it's burning a little bit of memory, and it currently is being served by these pods. So that gives us our service to pod mapping and our replica set, how well that's scaled. And also notice, and this is where the clever bit starts coming in. We talked about how Instana learns and understands the relationship. So what we're looking at here is a formal definition of a Kubernetes service, because hopefully traffic is flowing through that. So we have a logical service, which is the implementation behind this. And through that context that we learn, we can navigate then directly to the logical service. So now we're essentially seeing what the end user sees, who's consuming this service via a web page. So we have our key performance indicators of rate, errors, and duration. We can see how well that service is performing. We can see how that service is related. So it's an entry service, so there's nothing upstream, but downstream it's using a database. And if we just put the calls on there so we can color this, we can see it's using a data store and a Redis cache. We automatically detect and track the endpoints. So again, for each endpoint, rate, errors, and duration. So we can see for particular endpoints causing us any problem. But again, there's a whole set of standard alerting on that. If the error rate was to suddenly increase, or the latency was to suddenly increase, you would of course get an automatic notification of that, and then the root cause analysis kicks in, and you'd get a root cause report. If we look at the log messages, so Instana does pick up some basic log information. So if your code is using a standard logging framework, we instrument those logging frameworks, and we will pick up warn and above error messages. So I can drill down on that error message, and now we can see all the traces where that error message occurs, and drilling into one of those traces, we can then see where that appeared, and we get our details to get all the info. So it's an external call that comes in, hits this endpoint of this service, and it gave us an error, and we get the drill down on the error there and the full stack trace. Again, that context guide is here because we are constantly learning where everything's running and how everything's interconnected. So we know that for this particular trace, it's this service running on this node, which is in this container as part of this pod, as part of that worker node, as part of that Kubernetes cluster. And all this, of course, is hyperlinkable, so we can go straight to the pod. And because we've enabled the Humio integration for this environment, we can then drill in context straight into Humio. So we've got a unique pod ID, so we're using that then as that unique key that takes us into Humio in context, and also the time range comes across. I was looking at the last 10 minutes in Instana, and we're looking at the last 10 minutes here in Humio. So that would also work if you were looking at 2 hours last week, for example. That would come through, and of course we've now got a bunch of extra info messages here that are in the log that Instana doesn't pick up, so we can investigate further inside Humio, looking in more detail at those log messages. At this point, I think I'm going to hand over to Grant, who knows considerably more about Humio than I do, and he can then take over and talk to you about in more detail about what Humio can do. Over to you, Grant.
Thanks, Steve. So, like Steve showed, that's Instana's a great tool for tracing, and then given that one button to Humio, you're immediately hopping into Humio and getting context around all of your around that error. And as we'll see, there's some really interesting things that Humio can do to allow you to explore that data and learn more, and it really complements Instana in a great way. So what we're looking at here is that repo where that data was going, that the robot shop data was going. As you can see, we have very similar data in here. We have all this context around namespace, and we have all this rich data when we look at all these fields that are actually available. And to be open, I overdid it a little bit. So we added a lot of metric beat data, looking at Docker containers and looking at the Kubernetes nodes and the Kubernetes workers. And so we have a ton of data in this repository. And what I wanted to show you real fast is, since we talked about ingest and index-free logging, one of the interesting things I did with this project is I would say that the robot shop demo is really indicative of many microservices. The logs are actually quite different because we have Redis and we have different things going into the system from different parts and pieces of this microservices application. And I don't want this parser to scare you in any way, but what I was working with this parser is based on the application. So was it the cart or the catalog, the user? These things all had different logs. Some of them were in JSON, some of them had JSON in parts of the message, some of them didn't. And so I wrote a fairly big parser to essentially tease out lots of really interesting information. So, for instance, this looks like a really standard, web log or a common log format. And so what I'm doing here is I'm actually extracting out the source IP and the URL and all those things you would expect. So then we have that rich data, so we can more easily search it. Now I could I could simply do a string search if I wanted to across all of my data, but actually having the context with the fields is really valuable. So we can do things like, let's just search web. And so we're pulling out all of the results in the system that actually just have web in them. So we're able to do that index-free searching across all these things. And these are mostly references to the web container, but we actually see the logs here too. And so once we have a parser and we have these logs, where things really come together is when we start building dashboards with this data. So we're able to use the log data in order to come up with metrics. So we know how many users have logged in the last minute. And then here's all of our errors across the system. And if we remember back to Steve's demonstration, the error that he showed from the user application was a unique ID test was failing, and we see that here too, and we see a count. There's some other errors in the system as well. So the payment system in particular has some errors. But in addition to this application data where we're seeing these errors, we're also looking at the network, the CPU usage of all the individual applications in the robot shop, the memory usage of those as well, in addition to what pods are running. What are the running pods and what are the running the Kubernetes pods as well. We're able to extract all this information out of the logs and create these really rich dashboards. So to provide a little bit more context, I call it web stats, but this is the proxy stats. And with this, we're able to look at the errors per minute over the last hour. we're looking at the actual proxy upstream requests. So we actually see the distribution. Let's zoom in here a little bit. Let's go to 30 minutes and look at a little bit more fine-grained data here. So we're actually able to see what the web system is, the downstream applications and the amount of requests. We're able to see the responses by the services. But so what I've actually done here, just to give you a little bit of an idea, is with this regular expression, I'm actually extracting the service name from the URL. So the web proxy is hitting /API/service. I'm actually extracting that service and then using that in my group by statement later. So this is where that variable extraction at query time comes from. So even if I'm sending somewhat structured data, maybe I want to dig in a little bit more and extract something valuable. And so I'm extracting that user, and then we can go ahead and let's sort by status. And we see that the payment system, the method post, is getting 500, and there's been 158 of them in the last 30 minutes. So there's all this really interesting information you can pull out of these logs. The top URLs, that's very similar to what Steve showed as well. So we've shown this. Oh, one thing that I'd like to touch on is all of these things we can actually turn into alerts in the end. So if I were to, I can't grab it because that box is little there. Let me take this query. So I'm going to take this query that we had here, which I'm looking at everything from the web that has a status code greater than 500. So that's an error, and then I'm counting. And so any of these error counts or things like that can really easily be turned into an alert if it were a live query. I can save this as an alert. And so we can just call it error rate high, and we'll email the ops team, and we can choose a notification. So you can use all of the power of Humio in these alerts as well. So you can do variable extraction and things like that. If I wanted to, just pull out 503s, I could just pull out 503s, or we would just do equal in that case. To pull out 503s if I wanted to. So maybe I don't want to include all 500s, or I'm looking for a specific error. I could also pull in a string if I wanted to search that and just extract that string that had the status code errors. So that's how alerting works in Humio. Some of the other things that I'd like to share with you that was fun that we built for this project is a Kubernetes dashboard. So we can take all of this data. So we have the pod CPU usage, pod memory usage, number of running pods, pending pods. And so if the pending pods were above 10, we could send an alert, or I can turn this box to red, for instance. But one of the really interesting things Humio can do with this is we can specify parameters in the dashboards. So in particular, we can look at namespace, and I've added these namespaces here, so we can actually look at the parameters, not just for the robot shop, but let's look at the actual pod information coming from the kube system namespace. And so just by selecting kube namespace or robot shop, I'm changing the context of that dashboard. In the case of these pods, the Kate's workers apply to all those nodes. So it's really easy to build these rich dashboards that you can then change the context of. So you're not having to create dashboards and dashboards. You can actually simply add parameters to the dashboards to make that possible. Some of the other interesting dashboards, just to give you a flavor. This one was kind of fun. I extracted all of the shipping data from the log messages. And so if we were to look at these, these queries, I'm actually doing variable extraction here as well. I'm pulling, because the log messages, is pretty basic. It's like country shipping to city. So I extract city and country from that, and then use that. And so one of the things that we talked a little bit about parameterized dashboards. So when we have this index-free setup, I can just, give me all the entries that have Spain in them. And because I'm looking for certain log messages that are going to fit this, I can build, or simply just put in Spain, and now I'm just looking at all the shipping information from Spain and what users in Spain ordered in this case, and then what the cities were. when I extracted this data. So this is all really, really easy to do, and all based on logs. And I guess the last thing that I'd like to touch on that we mentioned, or that I referenced a little bit earlier, is taking observability out of just the context of, SREs and things like that. And we're getting a little bit of taste for this too. But just one of the things that I did is we knew the payment system had errors, so don't let the red box worry you. But so we're actually looking at the distribution of errors between 200s and 500s for this. But one of the things that I thought was interesting that I could do is actually pull out numbers from the carts or from the dispatch service. The dispatch service had cart total and cart tax, and so I just summed that data over the last 24 hours. So we could look at that in the last 30 minutes, and these numbers, the robots in the shop are actually quite expensive. So even in 30 minutes, my gross revenue is $570,000. The tax on that is $95,000, and then the shipping for all that is $22,000. And all of this is being done by these queries where I'm essentially summing up the carts, summing up the cart totals, and then formatting a little bit to get it into that that pretty dollar format as well. So that gives you a little bit of taste of the query language and the power that you can get from an index-free logging system. Not only can you work with metrics and have that context in your dashboards, but you can actually extract business value as well from these logs. The number of orders and things like that. So it's extremely powerful. I think that covers, kind of a good taste of everything Humio in the dashboard. I think, did we have some more slides, I believe, Steve?
Oh, that's it. I think we're just at the question and answers now. If anyone has any questions, tap them furiously into the Q&A box in the GoToWebinar, and we'll be able to answer those.
Awesome. So yeah, thank you both, Steve and Grant. It looks like right now we have a couple of questions, but feel free to submit questions as you have them. The first one is, how is the Instana agent installed onto Kubernetes?
That's quite easy. If you're using Helm, which I think most people are on Kubernetes, there's a Helm chart for the agent. So that's very easy, just a Helm install that can be achieved with one line. If you're not using Helm, we do have on GitHub the manifest files, so you can do it with a regular kubectl. And essentially the agent is a daemon set that runs on Kubernetes. So there's one agent on each worker node.
Okay, great. I have one person asking a question. I'm going to go ahead and unmute Kartik. I'm unmuting you right now. You can go ahead and ask your question.
Yeah, thank you very much. My question is that I just seen this. It's a index-free searching is available if we integrate Humio with this Instana. So I'm from Vodafone and we are using Instana in our production. So and for this searching we are using this Splunk. So my question is, how is this different? I mean, what is the basic difference between this Splunk and this Humio? I mean, what are the advantage over the Splunk?
Sure. So the real advantage to index-free logging becomes the amount of the amount of machines and the amount of CPUs and disk you are dedicating to your logs. So I mentioned this a little bit earlier in the talk. Because we're not creating these really large indexes, when you send your logs to Humio, and let's say you send a terabyte a day, that only results in 100 gigabytes that's stored, and we do replication factor. So these are really concerns when you're hosting it yourself. So many people that are running Splunk are hosting Splunk themselves. So they have these concerns. You're only storing, you would essentially result in storing 200 gigabytes a day. And so if I wanted to store 30 days of data, I only need 600 gigabytes of data. Or I'm sorry, I need a total of 600 gigabytes of storage. And so it's really easy to build this in scale, and doing it, we can generally handle a terabyte a day on a 32 core system with 32 gig of RAM, and sufficiently fast disks, NVMe's or SSDs can handle a terabyte of data. One machine can handle a terabyte of data a day. So for redundancy, you'd want 3. Of course, and to have the replication factor, but generally the Humio footprint is going to be much smaller than a Splunk footprint or perhaps an Elasticsearch footprint. When we're working with customers that are moving from Splunk or Elasticsearch, they were running 20, 30 hosts before. They're generally having to run anywhere from 8 to 10 to replace that, because we're not using a ton of overhead up front indexing the data. That's where a lot of the CPU time is spent. We spend that CPU time at query time and only for the data you're looking at, not for data you're not looking at.
Thank you. Thank you very much. And the one more thing I wanted to know, Humio is a natively available service, or do we have separately, there is a separate configuration for the same?
It is separation. It is separate. So whatever your it's similar to what you would do today, whereas you're using Instana and you're using Splunk agents, send your data to Splunk. You would use an agent that's compatible with Humio, like FileBeat or Logstash, or some Splunk shippers are compatible with Humio as well. And you can send your data either to your own Humio cluster that you're running on-prem or to our cloud environment.
Yeah, for the demo.
Thank you.
For the demo, it's just running FluentD, and it's using the Elasticsearch shipper to ship to Humio.
We have a couple more questions. Michael just wants to kind of piggyback on that, and he says, so you need 2 daemon sets, one for Instana and one for Humio on each node?
Yes. So you have one. You'll have a daemon set, which is the Instana agent, and if you're in a Kubernetes environment, you'll probably then have another daemon set, which is typically FluentBit, which does the log shipping.
Okay. And then, so Ray wants to know, with the alerting in Humio, is there some sort of intelligence to deal with repetitive entries?
Yes, I didn't really use an advanced query, but you could essentially collapse those things. You can collapse those things down using a few more additions to the queries to essentially only have one, crunch that down into one alert or one, not repetitive alerts. So you're not getting, alerts after alerts for each individual entry, for instance.
And we have one more question before we run out of time. And if we don't get to any more of the questions, we'll follow up afterwards. But the final question we have is, can we collect Kubernetes master API event with EKS? What about CloudTrail integration?
I don't believe you have access to that with EKS. However, with CloudTrail integration or any other integrations such as, let's say, CloudFront logs or CloudWatch logs, most of our customers that are integrating that data in are using Lambdas. So when CloudTrail or CloudWatch puts the data on S3, a Lambda fires that sends that data to their Humio environment.
Great. Okay, so we have run out of time, but we will follow up with these 2 final follow-up questions from Michael and Paraz. I'm sorry if I mispronounced your name, but we will follow up with your questions afterwards. But yes, thank you everyone for coming and for joining us today. Feel free to reach out to us if you have any further questions. And thank you both, Grant and Steve.
Hey, thanks very much for attending, guys.
Thank you for joining.